Hi guys, welcome to my computer. No AutoCAD today. Today I'm going to do a quick introduction on PLC programming. Now down here you can see that I have a little icon with a ladder. That's the programming software SLC-500 from Rockwell, Allen Bradley. And beside it there's an icon for a program called RS Links. That's going to establish our communication between the computer and the PLC processor. So that's the one you want to run first. We're not connected to a PLC right here. I'm sitting at home and I don't have a PLC at home, but this is the default opening screen here. Now if we were plugged into a processor, you would go to communications and hit RS-Who. I've just told the computer to sweep the ports on the computer for a connection with an Allen Bradley processor, and it's looking, but it's not going to find anything. So we'll just do this manually by clicking on communications and configure drivers and open up the little box here. And here's some configurations that you might have. At work I'm using an RS-232. It's actually USB on one end and RS-232 on the other end. And then I have that cord plugged into an RS-232 on one end, which turns into the Allen Bradley specific connector at the other end. So I actually have two cords plugged together and then plugged into my USB. So if you have an Ethernet connection or some kind of other configuration, you can go ahead and select that and click Add New. So that's the default driver name for this particular configuration, and you can name this whatever you want, but we're just going to leave it at that and say OK. My computers at work for the USB are on COM 6, one of them, and one's on COM 8. This is all going to basically be set up automatically if you are plugged into a live powered up processor and you've selected the proper configuration. Device PLC channel 0, that's exactly what you want. And if we were connected, we could just hit auto configure and it will actually establish that link for you. Your computer will not go online with the processor, it will just make the link for it. Okay, so now we're just pretending that we're linked to a processor. Okay, and you can have a whole bunch of drivers loaded in here, and they're running, they're not running, whatever. You can control each and every one of them and configure them here. Okay, so this is the one we want, and we say close this, and then we can go ahead and minimize the links program. And we're ready to open our programming software. So that's this, the RSLogix, which is the SLC-500 program, which is the platform for programming all of Allen Bradley's ControlLogix processors. So I just want to turn this off because sometimes that's not there when you open this, and that's a real handy thing to have when you're actually programming. So I want you to be able to get to it, and to do that, go to View and Online, and it gives you that, and go ahead and snap it in there, because you can go online and offline and upload and download, and it shows your forces, it shows your online status and stuff like that, so it's good to have. Okay, I have to make this quick because the family's coming home shortly. Okay. So we would go to File, New, and select a processor. This is a downloaded version of RSLogix, so you can see there's not many processors here to choose from. We'll just select the 1000 and say OK. And you will get this default construct screen. And you can see here it says LAD2 main prog. Right, that's the main program. This is the default screen. This is where you're going to be doing your programming in. As you advance, you're an advanced user, there's other things you can do here and string programs together. All kinds of different things you can do there, but for now you're a beginner, so let's say just leave it at that. Okay. Again, you can control controller communications and whatnot in some of the other things here, and string your ladders together. That's advanced, right? But down here you're going to be using this, okay? Your inputs, outputs, your binary bits, and timers, okay? So let's just go ahead and get started. Again, here's the end rung, and there's only one rung here. It's an empty program, and this is a computer program, so it's going to have an end. Okay, so we're just going to select that by clicking on there. And here, up under the User tab, these are the tools under the User tab. These are tools, timer on, timer off, return a timer, and so on, under some other tabs, but basically we're going to be staying here in the User tab. And under that tab, we're going to select Add Rung. Okay, just throw in a few rungs just to get us some room to work here. And you can see the end rung stays at the bottom, of course. It doesn't matter if the line or rung above it is jumping to a subroutine somewhere, or if it's sending you to some kind of loop. It doesn't matter. The end rung is still going to be there. Okay, so again, that's red, so we've selected that rung. This is the rung that we're working in. And we can go ahead and start loading it up. Now this, I should make myself clear that if you're not an electrician or an engineering technologist, which is a minimum standard to actually program PLCs in an environment where safety matters, such as machinery and whatnot, you're not going to be programming PLCs anyway. So I'm going to cut all the child's play out and just get to the meat and potatoes of programming. In particular, I'm sure you're all aware of how an input and an output works, right? We have an input here when it's, so grab an open contact, and you see how I've grabbed it and I've dragged it down here. So you want to drag your tool down here, and as it approaches the grip, see how the grip turns green? That's saying, okay, you go ahead and drop that there. Okay, so if you want, you can just go ahead and throw some things in there. We'll throw a closed contact up here, right? Maybe a closed contact down here, and some coils over here. Okay, so you're all aware of how an input and output works. If there's an input here and it closes, then this output actuates, and it's simple relay logic. Okay, I'll show you how to program these quickly. Say we want to monitor control power, so we click on this one and say down here input, and it brings up our input matrix. Okay, and as you can see, we're at 0, 0. So here it confirms input 0/0. So this is monitoring the actual input terminal on the PLC input 0/0. The beautiful thing about this processor is, okay, it has 10 24-volt DC inputs available and 6 AC or DC outputs available, depending how you have it wired. The line voltage for the processor is 110 volts AC, and it actually creates its own 24-volt DC internally and offers it on a terminal on the input terminal side, so that you can tap off of the processor and power your devices if you so choose. Okay, so this input 0/0, we're going to say under symbol, control power on. Or we'll say control power detected. Detect. Okay. Now, to assign that there, you have to actually grab this little bit here and drag it up until that little grip there on the contact you want to assign it to turns green, and go ahead and drop it there. And you can see that this contact has been assigned control power detected input 0/0. Okay, so in other words, this will actuate and close, if you will, when your processor detects 24 volts DC live on the terminal input 0/0. And this, we're just going to leave that a closed contact for now and get programming that later. Okay, so here we're going to say, so let's say we want a light bulb to come on. So we're going to make this an output. We're going to make it output 0/0. Again, down here, we're going to go to output and select 0/0 as our first one. And we're going to say control power on lamp. We'll make it LT for light. Okay, and again, you're going to grab that little bit and drag it there. Now, it doesn't matter what you put here in the description. The symbol is the real important part. But the description, you put absolutely anything you want, like a paragraph, like this lamp comes on when 120 watt control power is detected. Okay? And you can see it's just like any other computer program. You can close this. Like any other computer program, it's like a remark, rem. Okay, so you can, for more complex programs, you might need to put something in like that to recall exactly what your function of this bit here is. Okay, so where we're at right now is if we receive an input here, this would close, it would flow through that close contact, and it would actuate that lamp, which is assigned as an output. So you, regardless of what voltage, if you have it wired 24 volt DC or 120 volt AC, or whatever you have your outputs wired as, will be actuated here. Okay. So I showed you. Okay, there's timers here under the timer tab. Now there's time on, let's say. Okay, so if we wanted to throw a timer in here, okay, I'll just show you how these get set up. Timer, and it's looking for, what timer is it? Well, it's T4, and again down here you can see it says T4 timer. So T4 colon 0. So this is timer 0, the first one we're using. Okay. Now time base is seconds, 1.0. So this means seconds. Okay. So if it was 0.1, it would be tenths of seconds. Okay. So we're just going to go ahead and leave it at seconds. And your preset is how many seconds you want your timer for. So let's say 7 seconds. Okay, so now we've set this timer to time on delay. So when it's energized, okay, I know I'm being a little juvenile here, but when it's energized, it will time on over the course of 7 seconds, and when it's done, that's when this done DN coil will be energized. So when the association with that in the program is made, that means the timer has timed out or the delay has finished. Okay. That was kind of a goofy explanation, but I've got a little lamp test I programmed in here earlier to save a little bit of time. I just wanted to show you okay, how to associate. Let me get that timer back in there, okay? Just real quick here. T4 0, time base seconds, yes. Preset 7, yes. Okay, accum, by the way, is when the program's actually running. That is your counter. We'll actually be counting 1, 2, 3, 4, 5. Okay? So enabled is, so that's when the timer's energized, you would assign your reference to that as enabled, or if you want it to be assigned to when the timer has actually finished timing, and that's DN for done. Okay, so we could open up our timer matrix here, okay, and you can see timer 4:0 enable DN, so that's done, so that's the one we want. So we could grab that bit and drop it on that contact. So that contact is now, you can close that, that contact is now associated with that timer. So when this timer, when this timer receives a signal here and begins the time, when it's done, because it's a time on delay, when it's done, this associative contact will in essence close and allow this coil to be picked up. Okay, so I'm just going to save a little time here and get rid of this stuff and open a lamp test program that I wrote. Save changes? No. Okay, so this is just a quick lamp test that I wrote. so that you can see what like a finished product might look like. Okay, now there's a mistake in here, and you can see it here. So I have a reset, at a reset circuit, an automatic reset after 7 seconds of this timer. Okay, but I'll just quickly walk through this because control power on, so input 0/0, so it's detected the power, so it would flow through there. It would actuate this coil, which is an internal bit, B3. Okay, it's not an output. This is not a lamp or you know, a solenoid or anything like that. This is an internal bit, B3, and to assign those from the matrix is here under binary, B3. Okay, so B3/0, and you can see that I've got B3 0/0, B3 0/1, B3 0/2, and if you go into your matrix here, you can see that B3 0/0 is initiate, B3 0/1 is do lamp test, B3 0/2 is reset. Okay, so let's just get to actuating some of this. Now they make an emulating program so that you can write something like this at home and then emulate it as though it's running in a PLC. I do not have that program, so we will not be able to emulate this running. All I can do is toggle bits, and it doesn't work like as though it's actually running in a PLC, but if you put this into a PLC, it will work just fine. You can just do this at home, drop it on your thumb drive, and then drop it in your computer at work and download it to your processor. And I say download it to your processor because when the program is going from your computer to the processor, you're not uploading. You have to think in the frame, in your mind, in your mindset that you're the processor, so you're downloading this program into the processor. When you upload, you're taking the program from the processor to your computer. I know it seems backwards, right? Oh, my mouse. There we go. Okay, so this actually is incorrect here, but I'll show you how to fix that. See how it says T4-1 and EN for enabled? Well, first of all, this timer is T4-0, not T4-1, and I don't want it on enable, I want it on done, so that when this time delay is finished, I want this contact to close. So you can see on these closed contacts that when the electricity is able to flow, so to speak, it's highlighted on each side of the contact. Okay, so that means yes, it can go through, but it cannot get through here. As you can see, it's not highlighted. So let's actually right click on that and toggle bit. Okay, so when I toggle that bit, it shows highlighted there. So even though the contact doesn't change, it's an open contact, but it shows that it's actuated and it's able to flow through that contact. Okay, so as you can see, this would have actually, in real life, that would have been actuated because there's nothing stopping the flow here. So I know this is kind of crazy for a lamp test. I've got initiate and everything else, but okay, so control power has been detected. 24 volts DC has been detected on terminal input 0/0. There is no reset, so it goes ahead and flows. This I'm going to toggle, and you can see this contact here. You see how it's associated with it, B3 0/0 initiate. Okay, actually actuated when I actuated that coil. Okay, so toggle that bit off, and you can see it also went off. Okay, and to do that, so say we wanted, back to the user tab and grab an open contact and drop it there. So say we wanted this one also to actuate with do lamp test, B3 0/1. Okay, so it's just a question mark, right? It's just a contact, not associated with anything. But we wanted it associated with that bit, so we open up our binary matrix, B3 0/1, do lamp test. So we grab the little bit from here, right? grab it and drag it to the grip, turns green, and we drop it. Do lamp test. Okay, and as you see, it's just a copy of that right there. But that's how you make the association. Okay, it's already programmed in your matrix here. So this would be a redundant contact. There would be no point to it at all, so we'll delete that. Okay, so far we're at, yes, we do have control power on. Initiate, so I'm going to toggle that on. So go ahead and initiate. Now it's waiting at here and here, B30/1, which is what? Do lamp test, right? Well, we're not at do lamp test yet because it can't get through here. Of course, it's a regular relay logic, okay? Input 0/1 is what it's looking for. So now whether that's maintained or it's just a momentary contact, like a push button, okay, if it's a momentary push button and you press it and release it, I have this timer, and that's why I have this timer in here, so that we can hold the lamp test on for 7 seconds before the lamps go out. So it doesn't matter whether you're giving it a momentary or maintained contact here, because I have it latched in here. So let's just say that, okay, we did press the lamp test button. We want to test our lamps. So we'll toggle that bit on, and of course it's going to allow that to flow. And it's actually, this would have actuated had this been running in a program, but it won't do it because we're not in an emulating program and we're not actually running a PLC. So you will see that when I actuate that this latch contact should also come in. So I'll go ahead and toggle that, and it did, and everything associated with that bit, which is here, lamp 0, lamp 1, lamp 2, right? Do lamp test, do lamp test, do lamp test. Okay, so all those bits allowed these lamps to come on, which it's not showing that they're on, again, because we're not emulating and it's not actually running, but they would be on if it were a running program. So we're just going to toggle that off again, so it latches. So whether it's a momentary or maintained, it doesn't matter. It's going to latch, and it's going to start this timer, and it's going to keep those lamps on for 7 seconds before the reset occurs, which you can see I have a close contact for reset here, and a reset on the actual timer circuit itself. Okay, so we're going to go ahead and toggle that on, and now you can see that all our 3 lamps would be on. Okay, and when that happens, do lamp test, that closes, comes through, turns this timer on, timer T40 with a time base of seconds, with a preset of 7 seconds. Okay, a cum, so that would be timing right now, 1, 2, 3, 4, 5, 6, 7. When that is done, oh, this is incorrect. I'm going to fix this real quick first. Okay, so click on that, and we want to associate that with that timer. So we open our timer matrix by double clicking, and we want that on T40. Okay, and we want it on done. So when that timer is timed on and it's done timing on, we want that contact to close. Okay, so we'll grab that bit and just drop it on there, and it just replaces what's there. So again, T40, timer T40, done. So when this timer times on after 7 seconds, this contact will close. Okay, so just close that. I just had to fix that mistake. Okay, so here we are. We're doing a lamp test. The timer times 7 seconds. This closes. So we'll actuate that. Oh, you can't, because we're not emulating and it's not running in a program. And once again, you cannot force these timers or toggle them on or off. But at any rate, this is closed. This reset will be toggled, and of course, when you toggle the reset, Again, it's not going to do it, but what would happen, oh, it did do it, is that these reset contacts would open. Okay. Of course, it still shows closed, but they're not highlighted, so it's actually open, right? So when that happens, obviously that would drop out, right? This would drop out, which you can see dropped out the latch, right? All this would drop out. Of course, it's a reset, right? And reset itself would drop out. Okay. So I hope somehow this helped you with the internal bits and associating things. Did I show you how to do a branch here? I've done a couple of videos now. I don't remember where I was at on this one. What I'll do is put a branch around here just to show you in case I didn't, and that's here under the user tab. So this is the branch icon. You can just drag it over here and drop it there. Now you can see what it did. It messed up your whole line, but don't get worried. Just grab a side of it and okay, that was a very bad example. Grab this and put it back where it belongs. Okay, grab this side of your branch and put it there. Now you can see you have your branch around that coil. Okay, your parallel circuit, if you will. But that just shows you how these internal bits work. So okay, so that's all in your binary matrix. So it's like having an output without actually having an output. Okay. Again, I just wanted to get past some of the horse pucky that some of these other guys try to feed you. But here's your input and here's your output. Congratulations. But you see how it says 1761 micro here under here? That's because this program has been verified. Before you run any program in the processor, you'll have to verify. That's up here. Verify project. Okay, of course I have errors. It's not viable. I have a branch here that's doing nothing. That's probably the error right there. So delete that. And now if we wanted to, oh shucks, deleted the whole thing, didn't I? But anyway, I hope that helped you guys. And just so you know, I did download AutoCAD 2017, and we'll be testing that. This is just a trial version. I set it up the way I like my tools and stuff like that, as you'll be able to see here momentarily. I have 28 days left in my trial. I'll start the drawing. Start drawing. And you can see I have it set up the way that I like my tools. Oh, see, it runs a little slow. Like that, okay? But here's AutoCAD 2017, and it has all the 3D stuff in it because it was the free download. So they're going to give me the whole schlemiel. Basically, it works the same as any other of the AutoCADs. Okay, but hope I helped you guys. Talk to you later. Be good. Have a nice evening, day, morning, night.